This question is essentially asking us about differentiation from first principles, guiding us through it. So if I have the curve y equals 2x squared, it would look a little bit like this. You don't have to draw that accurately, but I think it helps. Rather than like having it go over here, it's good to have the kind of correct shape. And we're given a coordinate 5 because it's y equals 2x. That would give us, sorry, not 2x, 2x squared. We would square the 5 to give 25, times it by 2, we're going to get a y coordinate of 50. And then somewhere a little bit further along, we've got a coordinate 5 plus h, and that one's going to be 2 times 5 plus h squared, and I'm not going to expand that for the moment. We're asked to find this is point A and point B. And then we're asked to find, or show the gradient of the line is 20 plus 2h. So here's my line. And it has a run and it has a rise. The run is very quick to see. It's just going to be h. The rise is going to be the difference. It's going to be this value, 2 times 5 plus h squared, minus the 50. So let me expand that out. I'm going to deal with the h, I'll have the h first. It's going to be h squared plus 10h plus 25. Okay, just expanded this double bracket. So I did it the other way around at h squared. I'm going to get 5 times h. I'm sort of doing this the wrong way, aren't I? But, and then h times 5 and 5 times 5. Okay, hope you can see where that's come from. I still need to minus the 50. And then that's going to give me 2h squared plus 20h plus 50 minus 50. And these cancel. So the gradient of AB is going to equal rise over run. It's going to be 2h squared plus 20h divided by h. And actually this cancels with this and with this. So I'm left with 20. I'm going to write the 20 first because they have in the answer. 20 plus 2h as required. If you're not completely happy that I can just cross them out and think about factorizing, I can factorize out the h. Then I'm going to get 2h plus 20 over h. And now you can see a bit more clearly that they do cancel. But it's okay to do that because I'm adding them. I can just cancel one off each of them. Okay, nice. Done that one. Explain how the answer to part 1 relates to the gradient of the curve at A. So essentially, like we have control over this point. We can move it further away from A, or we can move it closer and closer. And as it gets closer and closer, it will start to approximate the actual gradient at A. This is how differentiation from first principles works. So when I move it like to here, they're going to be very, very close. It's like almost going to be like the tangent. And what I can do is I can essentially let h become really small. So as h becomes small, the gradient of AB, just want to look at the question, will tend, I don't know how exactly to write this, will converge or become closer to the gradient. What does it say? Sorry, the gradient of the curve at A. Um, and I don't know, you could even add this bit, gradient of curve at A will actually equal the limit as h tends to 0 of 2h plus 20. And as h tends to 0, this disappears, and we're actually going to get this gradient 20. Now, yeah, I just checked the mark scheme, and they do expect you to write about 20. Yeah, it sounds a good idea, but you would get a mark just by showing understanding of the limit. So I think, this is the best bit, but this is okay as well. Now we're told that the normal to the curve at A meets the y-axis at the point C. Find the coordinates of C. So the normal is going to be this line that's at a right angle to the what you would have if you had the tangent at A. Sorry, I've not quite drawn that in the right place here. So the gradient at A would give you the same gradient as a tangent, and then the normal is at a right angle to that. So the normal gradient will equal minus 1 over 20. It's the negative reciprocal of the gradient at A, because the two of them have to multiply to give minus 1. Now I can use y minus y1 is equal to mx minus x1 for the equation of this line. Now remember, I'm looking at point A, so I've got x is 5 and y is 50. And that's going to be my line. Now I'm actually simply asked to find the coordinates of C. That's where the normal